Okay, so we now look at the question 2. Where should try? Should 5. Should 5. We now go to question 2. Question 2a. We want the integral of x3 of sine 3x cos 5x dx. This one, if the powers are all odd, it's a bit tricky to change the other one to sine. If we change sine to cos, what will happen will be we'll have 1 minus cos squared x, and then cos 5x sine x dx, like this. This is sine squared, this one. And then one of the signs as the main this here. Then you have 1 times this whole thing. We get cos 5x sine x dx minus cos times cos. We have cos 7x sine x dx. Then we let u to be cos x. Then what to be du? Du is going to be negative sine x dx. The same thing will happen here. So we're going to have u5 minus du. And then this one will be plus now. u7 du. Now why to be plus? Because we want to put this minus outside. Then there's already a minus. So it becomes plus. So we integrate to have u6 over 6 plus u8 over 8 plus c, which is negative cos 6x over 6 plus cos 8x over 8 plus c. This one is a bit easy. So remember that what we have done here is to write sine squared and then sine x and then cos 5 x dx. And then we know that sine squared is 1 minus cos squared. That's why we had to come to this one. And then for b is the integral of sine 6x dx. So use the reduction. that we did for which one? For sine nx dx, we have the reduction of this. So you take n to be 6. So because he knows that you've done the reduction, he may not even ask you to do a reduction. He will just ask you, integrate sine to the power 6x dx. He knows for you to get it, you need to use that that method there. We go to C. C, the integral of sec 3x tan x dx. And then D, my phone can go off, so let me just put the question here. Cosec 5x cot 5x dx, and then E, the integral of sine 3 ln x and then cos 3 ln x over x dx. Okay, so let's get back to C. C, this integral here, we capitalize on sec. Instead of writing it as sec 3, we'll write it as sec squared x sec x tan x dx. Why are we doing that? Because we know that if we let u to be sec x, its derivative is going to be sec x tan x dx. So we can do a substitution here. We'll have u squared, then this whole part becomes du, which is just u3 over 3 plus c. So we have sec 3x over 3 plus c. A bit easy there. Then D, we have cosec 5x and cot 5x. But we have this nice identity that is coming from, if you have sine squared x plus cos squared x is equal to 1. What if you let u to be tan x? What's the derivative of tan x? Or derivative of tan x is sec squared. There will be one more sec standing alone. So from this one, if we divide by sine squared x, divide by sine squared x, divide by sine squared x, we'll get 1 plus cot squared x is equal to cosec squared x. So I want to use this identity there. So we'll write this guy as the integral of cosec squared x squared, we know it is 4 now. And then one of the cosec will release it here, x, and then cot 5x dx, like that. Let's see. Well, let's use it in reverse. Let's use it in reverse. Let's keep the cosec and change cot because of the integrals. So let's write cot squared x squared, and then keep one cot here, and then fix the whole cosec 5x dx. Yeah. Then we know that this guy here will now be equal to, so say cot squared x is equal to cosec squared x minus 1. Yeah. So use it in this form. So say this is the integral of, where there is cot there, we write cosec squared x minus 1 squared, and then cot x cosec 5x dx. Then we let u to be cosec. Let u be cosec x. Then you see that du is cosec x cot x. It's minus. So it's minus. Du will be minus cosec x cot x dx. So we substitute now. It will be here, we put u squared minus 1 squared. Then this cot is here. One of these cosec is here. So we'll remain with, so I'll put the minus here. So we'll remain with the, we'll remain with cosec 4 there. And since cosec is u, then we'll have u4 du. Yeah. Because one of the cosec is here, so it is cosec 4 now there. Then the minus, it doesn't get, it's not taken by 4 because we have attached the minus to du. Then now we're integrating this one. So what do we do? So this is one question here. So we expand. So we have minus u4 minus 2u squared plus 1, and then u4 du. Although I know you can finish this one. This is u8 minus 2u6 plus u4 du. Then you remember what u is? U is cosec. So we have negative cosec 9x over 9 plus 2 cosec 7x over 7 minus cosec 5x over 5 plus c. So what I was doing is, because I know I'm integrating these u's, and I'm just increasing the power and dropping. So as I do that, I'm writing the actual u in terms of x. I hope you like this one. We now go to E. Maybe E is interesting. E. And my phone is still on, so I'm not, I can copy it. Sine 3 alienates cos 3 alienates over x dx. So the first question that we did had why that sine 3 and cos 3 and cos 5, but those are odd powers. That's one thing that we are picking from there. So because they are odd powers, we can change one of them. So we change sine into sine squared in x, and then cos 3 in x, and then keep that sine in x over x dx. Then change this sign into 1 minus cos squared x. So meaning that that one will multiply by the whole part. So we'll get cos 3 in x. We're now multiplying it by 1 in x dx over x. And then minus, we now multiply by cos squared. So we'll get cos 5 in x sine in x over x dx, like that. So what I've done is that, remember what we did, sine squared is 1 minus cos squared x. So when you multiply now 1 by this whole piece here, this one, we just get that whole thing here. Then negative cos squared multiplied by this whole thing here. So here you have cos 5, because we're adding, and then everything else comes the minus. Then now, because of the x which is down here, we let u to be in x first, so that it's the derivative u becomes 1 over x dx. So what we have now is something like cos 3u sine u du minus cos 5u sine u du, because that dx over x is just the du here. Then that's when now we say, okay, let v now be equal to cos u. Then dv is going to be negative sine u du. So that when we substitute, we have v3 dv negative, and then plus, and then plus, and then plus v plus v5 dv plus, because that minus, this guy is coming with a minus, so I have double minuses there. Then we'll get minus v4 over 4 plus v6 over 6 plus c. What is v? V is cos. So we have cos for u. What is u? U is ln x over 4. This is minus. And then plus v. V is cos u, but u is ln. So this is 6. Cos 6 ln x over 6 plus c. This is our integral. Like that one. And you can bring such integrals because you think there's so much to do there on that ln. And then you get stuck. But every time you see a ln in the numerator and there's x down, then you know that you don't need to use any bypass, just use substitution. You have everything that you need there. So tomorrow we'll continue. We'll have a class tomorrow, since next week is the test. We'll have a class tomorrow to look at this trig substitution. Though we did part of it, but now we use these questions here. We do question 4. The whole of it, the way I've done question 1, question 2, question 3. Then also do question 4, the whole of it. And then we'll start to sheet 6, where we explain the concepts there of the improper integrals. Yeah, improper integrals. So that when you do those improper integrals, then it will be cool for us. We can now start revising. Maybe Sunday or Monday, so we start revising up to Wednesday. So that Thursday you prepare on your own. Then Friday you write. I haven't been there to invigilate you. Okay, so we end here. Enjoy this evening as we support the Copper Queens. Moses, let's watch the game, man. Patrick, let's watch the game.
Yes, I will watch it.
Yeah, it's good we watch the game and then we go and start. Okay.